Hi, my name is Ajay de la Puente. Our research project focuses on the use of cryptography for electronic commerce, EMV cards, password security, and cloud computing. In this presentation, we will highlight the basic concepts regarding cryptography and network security. Cryptography is the study of techniques for secure communication. It transforms data into a secure form. It uses encryption, which is the process of transforming plain text into ciphertext using a key algorithm. Plain text is the original information before it is encrypted. Ciphertext is the obtained text after the encryption process. And a key is a mathematical value entered into the algorithm in order to produce the ciphertext. Cryptology also includes decryption, which is the process of transforming ciphertext back into its original text. Decryption and encryption can use the same key or a set of different keys. Cryptography offers 5 basic protections. Confidentiality. It ensures that only authorized users who have the key can access the data. Integrity. Ensures that the information is correct and that no unauthorized user or malicious software has altered the data. Availability. Makes encrypted files available from a central file server, but only authorized users can have access to these files. Authenticity, which is the process of authenticating a remote user. And non-repudiation, used to prove that a user performed a certain action. There are 3 basic cryptographic algorithms: symmetric encryption, asymmetric encryption, and hash algorithms. Symmetric encryption, in which we can find private key cryptology, uses only one key for both encryption and decryption, which means that the sender and the receiver needs to share the same key. Asymmetric encryption, in which we can find public key cryptology, uses 2 different keys, a public key and a private key. The public key is known to everyone, and the private key is only known by each individual user. Hash algorithms, in which we can find cryptographic hash functions, is a one-way encryption function because after the message is encrypted, decryption cannot be applied, and the original message cannot be obtained.
Hi, my name is Ricardo Bautista, and I'm going to be talking about cryptography for password security. As we are aware, nowadays we live in almost a total digital world in which people use computers every day to either check their emails, bank accounts, fill up applications, buying or selling products over the internet, sharing most of the time sensitive information behind every transaction, every login, every click. Since we live in a social world, security is a key ingredient to keep all parties protected, and passwords are definitely important because they're the first line of defense against attackers. Throughout times, passwords have definitely evolved. Back in the 1990s, when attacks were not as common as today, our recommendations for a good passwords were simple. They had to have upper and lower case letters, they had to contain digits or punctuation characters, they had to be easy to remember and from 7 to 8 characters long. Nowadays, these have definitely evolved and they're more strict, so they cannot contain words found in a dictionary, not to be names of friends, family members, famous people, not being less than 8 characters long, and not being a number and not containing spaces. Even with all these adjustments, there is still some alarming numbers when it comes to password security. For example, 90% or more of password granted will be vulnerable to be hacked. In 2013, 24 million customers at Zappos accounts were affected by hackers that got access to their names, phone numbers, emails, and partial credit card numbers. Last year, around 400,000 Yahoo emails and passwords were hacked, and in 2011, around 77 million passwords were stolen from Sony PlayStation networks. New ways to protect information through passwords are being studied, and cryptography using biometric features is the direction it's going. Biometrics is about those unique personal features such as voice, retina, face, and fingerprints that are used to identify an individual with high degree of assurance. Fingerprints are the front runners, and they will become the password of tomorrow. Um, the methods of matching fingerprints are based on the following processing systems. Room filtering, which is nothing else than what its name says it. It filters the image of the fingerprints to remove any kind of noise from the image. The filters used for these procedures is more accurate than other common filters. Normalizations, which consist on removing the sensor noise and finger pressure difference between capturing and processing the actual fingerprint image. Binarization, which consists of taking a grayscale fingerprint image as an input and outputs a binary fingerprint image. The intensity of the image is reduced from an original 8-bit pixels to 1-bit pixels. The downside of this operation is that not all the fingerprints image have the same intensity threshold, therefore a common image processing tool is used to determine the threshold. Finding the core point, as we all know in the fingerprints, are unique for every individual, therefore a singular point is necessary to be detected in order to classify the fingerprints efficiently. MD5 Digest utilizes the core point detections that comes after one of the core point is detected. The digest is calculated from. This algorithm is intended for digital signature applications in which the large files must be compressed in a secure manner before being encrypted. Elliptical curve cryptography as an approach to public key cryptography based on the algebraic structures of elliptic curves. The main advantage of this elliptic curve cryptography over the traditional cryptography is that provides more security with keys of smaller size. Lastly, some biometric cryptography are already in use, but they will be widely used in many applications such as biometric ATMs, cell phone and other handheld devices, web security, personal computers, e-commerce, and cloud computing.
Hello and welcome to this section of the presentation. My name is Pablo Gonzalez and we're going to be discussing EVM cards and cryptography. The acronym EVM stands for Europay, Visa, and MasterCard, which were the original founders of this type of technology. First, we're going to take a look at the background and also a general overview of EVM technology and how it's universally impacted the transaction protocols used around the globe. Next, we're going to take a look at the authentication protocols and how cryptography plays a role in these protocols. And last, we're going to take a look at the man-in-the-middle attack, which is the attack that is affecting EVM technology the greatest, and it was discovered by the University of Cambridge in 2010. So now we're going to discuss authentication protocols, and basically anytime an EVM card gets used, three-man authentication stages take place. The first stage is the card authentication stage, and in this stage one of several applications with cryptographic keys is employed. This can include the master chip authentication program, also known as CAP, if the transaction is taking place online, or basic ATM functionality keys if the transaction is taking place elsewhere. The second stage is a cardholder verification stage, and in this stage complex EVM negotiations take place, and the most common authentication techniques include PIN verification, signature verification, or no verification at all. And this stage is very dependent on outside factors such as special requests from the customer during card issuance, such as no PIN signature in the case where the customer may be visually impaired. And the third stage is a transaction authorization stage, and this is where the terminal prompts the card into generating a cryptographic MAC address containing the transaction details, and the authorization request cryptogram is generated from the card containing all the transaction information and is again sent back to the bank with all that information in place. So now we're going to discuss the first attack that EVM is vulnerable to in the field, and it is perhaps the most important attack there is up to date on EVM cards, and it is the so-called man-in-the-middle attack. And what this attack does is it allows the user to successfully complete a transaction without a valid PIN number. The way the protocol works is the person will enter their PIN number into the terminal. This PIN number will then be sent back to the card and compared to the number that is actually stored within the card itself. If these two numbers match, the card essentially generates a hexadecimal number which validates the transaction, and this will successfully complete a transaction. If we look here in the screen, we can see the man-in-the-middle device, which is quite literally inserted in the middle of the stolen card and the terminal. And what this device does is it taps in at the exact time this validation is taking place, and it sends this hexadecimal number, which will validate the transaction and allow the purchase to take place. The attack is essentially requires redesigning the architecture of the EVM protocol, and this is something that is currently under research. The people that were able to pull this attack off are actually from the University of Cambridge, and they posted this in a popular article titled "Chip and Pin is Broken" in 2010.
Hi, my name is Marcos, and I'll be presenting cryptography for cloud computing. Advance in networking technology and an increase in the need for computing research have prompted many organizations to outsource their storage and computing needs. This new economic and computing model is commonly referred to as cloud computing. By moving their data to the cloud, customers can avoid the cost of building and maintaining a private storage infrastructure, opting instead to pay a service provider as a function of its needs. For most customers, this provides several benefits, including availability and reliability at a relatively low cost. While the benefits of using a cloud infrastructure are clear, it introduces significant security and privacy risks. In fact, it seems that the biggest hurdle to the adoption of cloud storage is concern over the confidentiality and integrity of data. The ecosystem of cloud computing cannot be completed without security algorithms, encryption, and security policies. Recently developed cryptography techniques aim to achieve the best of all worlds by providing the security of a private cloud and the functionality and cost savings of a public cloud. The core properties of a cryptography storage service are that the customer maintains the control of the data and that the security properties are derived from cryptography, as opposed to legal mechanisms, physical security, or access control. Based on the material review, we conclude that cryptography can be used for the following: proof of retrievability, homomorphic encryption, private information retrieval, broadcast encryption, and knowledge and serial knowledge proof.
Hello, my name is Ricardo Moreno, and I'm going to talk to you about cryptography for electronic commerce. 5 characteristics of cryptography and security are confidentiality, which ensures that the message stays secret, integrity, which ensures that the message is unaltered, availability, which makes sure that both users have access to the message, authenticity, which ensures that the message is not sent from an imposter, and non-repudiation, which makes sure that each user made an action on the process. Types of cryptography algorithms include symmetric cryptography, which 2 users share a single key, and asymmetric cryptography, where users use 2 or more keys, usually a private key and a public key. This is the figure for symmetric cryptography. A plain text is encrypted with a key, making it into ciphertext. The ciphertext is then sent to the receiver. The receiver then decrypts the ciphertext with an identical key as the first. This ensures confidentiality, integrity, and availability, but does not ensure authenticity and non-repudiation. An asymmetric cryptography algorithm takes a plain text, uses the receiver's public key, encrypts the message, makes it into ciphertext. The ciphertext is then sent to the receiver, and the receiver uses their private key to decrypt the message. As you can see, it covers all of the characteristics for a cryptography algorithm. This ensures the safest cryptography algorithm.